Now, in this section, let's talk about the last system architecture, that is about the database systems. Database systems are the most critical components in any architecture because when we talk about databases, one thing you must remember is that they carry a very high hack value. Why? Because databases hold massive amounts of information. If an attacker gains access to a database, the payoff can be huge because databases can hold customer records, payment details, intellectual property, or in the OT world, they can hold production process data, and this data can be sold, leaked, or used to disrupt operations. So, database systems are among the most critical parts of any architecture. And a database system, how it works, it uses DBMS or database management system that is used for managing and organizing data efficiently. And you run some CRUD operations, CRUD meaning create, read, update, and delete. These kind of basic operations you run to interact with the data. And important thing to notice is that databases allow multiple users to access and share information at the same time. And that then brings in a lot of vulnerabilities. Some of them are straightforward, like a weak access control or lack of encryption can produce a huge risk for the database. But there are also these aggregation risk and inference risks that come with the database systems. Aggregation risk meaning that even if individual pieces of data look harmless, when you combine them, you can learn something sensitive about them. And now with AI, this is becoming more common. This risk has increased because with AI, you can combine individual pieces of data and then learn something sensitive about the data. For example, a hospital database might separately list patient IDs and treatment codes, use segmentation to store these data into different tables separately. Neither of them looks too revealing on their own, but if an attacker combines them using some kind of AI, then they might figure out which patients are receiving treatment for a specific disease. And then this brings you in direct violation with regulations such as HIPAA and other healthcare regulations and PII data regulations. Then you also have inference risk, which is when you can guess restricted data indirectly. For example, let's say salary details of employees are restricted in an organization, but if a user can see departmental averages also and also knows the salaries of a few individuals in that department, then they can work backwards to infer the salary of the person whose data is supposed to be hidden. So, like this, now with AI, these risks have increased because these permutations and combinations can be run fast, and one does not need to be very intelligent in order to play with these combinations. So, yeah, for database systems now, the aggregation risk and inference risk has increased a lot. And in IT, databases at the heart of the things like online banking, shopping carts, and social media feeds. Whereas in OT, databases often take the form of historian databases that store sensor readings, alarms, and that process some real-time logs. And if attacker can corrupt that data historian, then operators could lose visibility or they may be tricked into making some wrong decisions. So it's important to understand that databases are high value assets, and whenever you are thinking of enforcing boundaries in your systems to protect some components, database system is one of the most important component that should have some kind of high security controls around it. All right, then that's all in this section. See you on the next slide.